Good morning students. Today in our notebook mathematics, we will take chapter number 1 real numbers of standard 10th mathematics as per NCERT syllabus. So actually in class 9th we have begin our exploration to the world of real numbers and encountered the so-called irrational numbers. So we will continue the same discussion on real numbers in this video session. So starting with the basic concepts of real numbers, let us consider and understand the basic numbers we have read so far. Considering this, we have read about natural numbers, whole numbers, integers, decimal, fractions, rational number, irrational number, and real numbers are set of rational numbers as well as irrational numbers. Once again, we will look all this together and try to understand the concept of real numbers. If I assume this as my universal set, this is my universal set, then n here correspond to set of natural numbers, that is the numbers that I can write in this form as 1 2 3 4 and so on. W here correspond to set of whole numbers which begin from 0. Z is set of integers which include negative number, 0 as well as positive numbers. Q correspond to set of rational number, and I will recall you what are rational numbers. So rational numbers are those numbers which can be represented in the form of P by Q, where P and Q both are integers and Q value is not equal to 0. And irrational number represented by Q dash is, here Q dash is a set of irrational number. So irrational numbers are those numbers which are not rational number. It is as simple. So the numbers which cannot be represented in the form of P by Q, right, are called irrational number. Now, looking at this, if I make a Venn diagram, it will look as follows. Here, I will keep n at the center, the set of natural numbers, because they begin from 1, 2, 3, 4 and so on to all positive integers. Now, except 0, all the numbers are natural numbers. So, 0 is an extra digit or number, I can say, which falls in the category of whole number. So therefore whole numbers are numbers which contains 0 as well as all natural numbers. Now if I come to integers, these contains 0 also, all set of positive numbers also, as well as it contains negative integers also. It means it contains negative numbers as well as all the elements which were present in the whole number. That means Z contains all the elements of whole number, that means all the elements of natural number as well as negative numbers. So integers contains all the whole numbers and negative numbers also. Now if I talk about rational number, so rational number contains all the integers because all the integers can be expressed in the form of p by q. Clear? So therefore all the integers, it means all the whole numbers as well as all the rational number, all the natural number can be represented in the form of rational number, and therefore rational numbers contain all the integers as well as some other numbers. So except rational number, whatever numbers are left, they fall in the category of irrational number. So irrational number are different set of numbers which does not comes in the category of rational number. They are not in the category of integers, they are not in the category of whole numbers, they are not in the category of natural number. They are completely different set of numbers. And real number, that is R, set of real numbers, it includes all the numbers which are rational q as well as irrational q dash. So all these falls under the category of real number R. So this was the concept of real numbers, and now we will move to our standard 10th first topic, that is Euclid's division lemma. So Euclid's division lemma is our first important topic given in the NCERT syllabus. So as the name suggests, the Euclid's division lemma has to do with the divisibility of integers. It says any positive integer, I will write here, it says any positive integer a can be divided by another positive integer b in such a way that it leaves remainder r, that is smaller than b. Although this result is quite easy to state and understand, it has many applications related to divisibility properties of integer, and we will generally use it mainly to compute the HCF of two positive integers within this topic. So first of all, let me begin Euclid's division lemma by stating algorithm. What is an algorithm? See, an algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Suppose that if I had any problem and I need to solve that, so I will follow steps for solving that. Suppose if I give you addition only, you will say first we will start from the ones digit, then carry on if carry is coming to the next digit, and then addition will follow and it will proceed till the end and you will get the result. This is a steps for solving a type of problem. Understood? Now what is lemma? Lemma is a proven statement used for proving another statement. A lemma is nothing but we will first prove a statement. Lemma is a proven statement, and then that statement is used for proving another statement. So it is as simple. An algorithm is a series of well-defined steps which gives procedure for solving a type of problem. And then lemma is a proven statement used for proving another statement. So let us begin our session by stating Euclid's division lemma. Right? So Euclid's division lemma states that given positive integers a and b, given positive integers a and b, there exist unique integer q and r satisfying a is equal to bq plus r. where R is greater than equal to 0 and less than B. It is quite difficult in maths language if you will understand. So let us take an example for understanding this. Suppose that if I take any number 17, and let us divide this number by 6. These are my two positive integers a and b, right? Both are positive integers and I am relating them with a and b. Then suppose that if I divide this 17 by 6, 6 2s are 12 and I get remainder 5. So this is my remainder, clear? And this number is my quotient. Right? And these two were my a and b, two positive integers which I took before. Now if I need to write this 17, I can write it as 6 2s are 12 plus 5. 6 2s are 12 plus 5, that is 17. Right? So here now I will change the symbols. This 17 was, previously I told you 17 was A and 6 is B. So this 17 is my A, 6 is B here, 2 is my quotient, so I can write symbol Q, plus 5, that is remainder R. And clearly from this statement itself I can see that we have came to our equation satisfying which we have written before, A is equal to BQ plus R. Now also I can find, previously we have written that this R value is greater than equal to 0 and less than B. So here my R value was 5. This 5 is greater than equal to 0, yes, and it is less than B, which is 6. So it is as simple, right? A is equal to BQ plus R. R is remainder whose value is always greater than equal to 0 and less than the value of B, that is divisor. Okay. So coming to our next session, this includes Euclid's division algorithm to find HCF of given two positive integers. Now first we have to recall that HCF of two positive integers, say A and B, HCF of two positive integers, say A and B, is the largest positive integer, say D, which can divide both A and B and leaves remainder 0. That means D is any positive integer that can divide both A and B, leaving remainder 0. Now let us see how algorithm works through an example first. Suppose we need to find the HCF of integers 455 and 42. The question is to find HCF of 455 and 42. So we start with a larger integer. Here among these two, the larger integer is 455 and we use division lemma. So 455 I will use this number, I will use as A. I will correspond this number as A and this number I will correspond as B. So as per division lemma we have to apply division lemma and we have to represent this number in the form of A is equal to BQ plus R. So how to do? We are doing this by dividing the number A by the number B. So clearly 42 tens are 420, 5 is left, here 3 is left, this is my remainder. This number is smaller than this, so this is my remainder. And how I will write? So I will write 455 as 42 multiplied by 10 plus this remainder 35. So now we have to consider divisor 42. For the next step, we will consider divisor as 42, and the remainder which we got, we will consider this as our B. That is, this 42 is our A and this 35 is our B. And we will again start the same process, that is, we will divide 42 by 35. So 35 ones are 35 and we are left with 7. Again, this number is smaller than this, so this is remainder. So we will write this in the form of that 42 is equal to 35 multiplied by 1, that is quotient, plus the remainder, that is 7. Now still we have not received our remainder as 0. So we will again continue this process, because in the beginning only we told that D is any number that is HCF that can divide both A and B and it will give remainder 0. But still our remainder is coming. So now we will again consider this 35 as A and this 7 as B and proceed with the same procedure. So now we have to divide 35 by 7. 7 5s are 35 and 0 is left. So now we will represent this 35 as 35 equal to 7 multiplied by 5 plus 0. Now we got the remainder 0. Our remainder is 0. At this stage where the remainder is 0, we cannot proceed any further, and we claim that the HCF of 455 and 42, that is HCF of 455 and 42 is the divisor at this stage, and the divisor was 7. So that is 7 is the HCF. So based on that example, now we will write down the Euclid's division algorithm and the steps required to solve the problem. So to obtain the HCF of two positive integers, say C and T, with C value greater than D, we follow the steps as: step 1, apply Euclid's division lemma. Okay, 2, C and D. Now we find whole number. Every time we will find whole numbers. Q and R such that the greater number, that is C, will be equal to DQ plus R, and the remainder R will be greater than equal to 0 and less than the value of D. Clear? So second step is, if R is equal to 0, that is, in our previous question, when the R value remainder was equal to 0, then the divisor at that stage, that is 7, was the HCF of the two numbers A and B. Similarly, if we get the remainder value 0, then here the divisor D is the HCF of C and D, and if R value is not equal to 0, then we have to apply division lemma to D and R. And as we have seen, we have continued our process one time, two time, three time. So we have to continue our process till the remainder we get is 0. So we have to continue the process till remainder is 0, and the divisor at that stage when the remainder will be 0 is the required HCF. So the divisor at this stage will be required HCF. In our NCERT textbook, example 1 is given. Use Euclid's algorithm to find HCF of 4052 and 12,576. So first step is, since I have to look after the two numbers and find out which number is greater. So I have seen that this number is 5-digit number and it is greater than 4052. So 12,576 is greater than 4052. So this number will be I will denote as C, and this number I will denote as D, as stated in our first step C. To obtain the HCF of two positive integers is C and D with C greater than D, we will follow the steps. So first I have found out that this number is greater, so I will give this value as C, which is greater than D. Now I have to apply my first step, that is apply Euclid division lemma to C and D. We find whole numbers Q and R such that this equation is valid. So first I will divide this greater number with this smaller number, and I will obtain a quotient as well as a remainder, and I will write in the form C is equal to DQ plus R, and I will also find that this R value will be greater than 0 and less than my D value. And if I will get this remainder 0, then I will stop my procedure. So let us begin our procedure. So first 12,576 divided by 4,052. So clearly it is already been solved in the textbook. So 4052, 3 is 3 2 is 6, 3 5 is 15, carry 1, 3 4 is 12, 0 2 4 and 0. Now this number is smaller than this number, so I cannot proceed further division. So I will write C value, that is 12,576, equal to D, that is 4052, multiply by Q, that is this 2 we have to multiply, plus remainder, that is 420. Now as I told you, if remainder is not 0, we will proceed with the values of D and R and consider these values, this value of D as my C for the next level, that is 4052 will be considered as C, and 420 will be considered as T, and again we will follow the same procedure. So in the next step I will divide 4052 with 420. So 420 multiplied by 9, 9 zeros is 0, 9 2 is 18, carry 1, 9 4 is 36, 1 37, and when we will subtract this, I will get 270. Clear? So this number can be written as this multiplied by this, 420 multiplied by 9 plus the remainder 272, and the answer will be equivalent to 4052. Again I find that my remainder is not equal to 0. Again my remainder value is not equal to 0. So I have to consider these two numbers again and apply the Euclid's division lemma. So my numbers are 420 and 272. Clear? So 420 is again greater than 272. This number I will consider as my C value and this number I will consider as D value, and we have to divide this 420 by 272. 272 ones are 272 and I will get my remainder as 148. So again my remainder is not equal to 0. So I will state this in the form this 420 is equal to 272 multiplied by 1 plus 148. So since remainder is not equal to 0, we have to consider these two numbers and again follow the Euclid's division lemma. So 272 and 148, this number is greater, this will be my C value, this will be my D value, and then we have to divide 272 by 148. So 148 ones are 148. Now if I subtract, I will get remainder 124. Clear? So this value is again smaller than this, so no further division is possible. So I will again represent this 272 as 148 multiplied by 1 plus 124. Since remainder is not equal to 0, we have to again consider these two numbers and apply division lemma. So 148 and 124, this number is greater. So this will be my C value, this will be my D value, and I will divide 148 by 124. So 124 ones are 124. I am getting remainder here 4, 2, 24 is my remainder, which is smaller than 124, and so no further division is possible. So I will again mention this 148 as 124 multiplied by 1 plus 24. Since remainder is again not equal to 0, so we have to consider this D value and R value. We are writing generally in the form of this only, no, C equal to DQ plus R. So that is why I am saying again and again we will consider these two numbers till we reach to a value where remainder is equivalent to 0. So again we have to consider these two numbers 124 and 24, right? And we will proceed. So again we have these two numbers 124 and 24. Clear? So this number is greater than this. This will be my C value, this will be my D value, and I will divide 124 by 24. So when we will divide 24 5s up, we get 120 and remainder is 4. Again this number is smaller than this, no further division is possible, and we will mention this 124 as 24 multiplied by 5 plus the remainder, that is 4. I can again see that the remainder value is not equal to 0, so we have to consider these two numbers and we have to proceed with Euclid's division lemma. Since 24 is greater than 4, this value I will take as C and this as D and apply division. So clearly 4 6 are 24 and I will get remainder 0. And we will state in the form C equal to DQ plus R. So C value was 24, DQ, that is 4 multiplied 6 plus R is 0. Now we are at a stage where the remainder is 0. So at this stage the value of D, that is C equal to DQ plus R, at this stage where remainder becomes 0, the value of D, that is here 4, since remainder is 0 at this stage, the value of T, which is 4, is HCF of the given two positive integers. So HCF of 1, 2, 5, 7, 6 and 4, 0, 5, 2 is 4. So dear friends, as we have completed and understood the process of Euclid's division algorithm, now this worksheet will test your ability and you have to solve these 3 questions and find out the HCF of the given numbers. This is the questions given in NCERT exercise 1.1 question number 1. So this will be your worksheet. You have to solve this and on Sunday we will solve these questions. So for any queries, visit our video on Sunday. Thank you guys.